Hey guys, what's up? I hope you're having a great day, and today I'm going to be going over Geometry Lesson 8-1, the example portion of it. So we're going to hop right in, and I'm going to do a few of these example problems, not all of the ones here on the screen, just a few. I'm going to start by going into what a geometric mean is. I'm going to show you how to solve these problems, and then hopefully I'm going to be able to explain number 10 to you guys and how I think it through. So the first thing to recognize is what a geometric mean is. Basically, it is when you're comparing a over x to x over b. In this case, x is the geometric mean, and this is useful when you're dealing with right triangles. I know that's terribly drawn, with an altitude. The altitude is usually this x, and you set up a proportion where x is the same, and what you get is AB is equal to x squared, or the square root of AB is equal to x. In which case, the square root of AB is the geometric mean of A and B. So, let's go ahead and go up here and take a look at these examples. So, we want to find the geometric mean between 1/4 and 4. So what you're going to do is set up a over x is equal to x over b, right? In this case, 1/4 is going to be your a, and 4 is going to be your b. So you're going to get 1/4 over x is equal to x over 4. Now what you do is you cross multiply, you get x squared is equal to 4 over 4, which is 1. Square root of 1 is 1. Alright, let's take a look at 3 and 75. The shorter way, so that you don't have to set up this equation each time, is you multiply these numbers and take the positive square root. So 3 times 75 is equal to 225. The positive square root of 225 is equal to 15. So the geometric mean between these two numbers is 15. And you can carry it out through all of these problems if you want to. That's what our homework is. Sometimes you will come up with an answer that is, it's like the square root of, for number 6, it's going to be the square root of 72. And what that comes out to be is, it probably goes out, yeah, it becomes the square root of 9 times the square root of 8, but that's 3 times the square root of 8, and then 8 becomes 3 times the square root of 4 times the square root of 2. The square root of 4 is 2, so that comes out to be 2 times 3 times the square root of 2, which is 6 times the square root of 2, which is this answer. Now, to finish up, let's take a look at number 10. We're going to find x, y, and z. Alright, so if you remember from the last video I put out, I showed you guys how to draw these proportions. So we're going to find x first. Okay, now because x is this altitude, you're going to be comparing the two smaller triangles, not the large triangle, because x is not a part of the large triangle. So let's take a look at the one on the right first. We know that this is the right angle, right? If you take a look here, we can see by the way this right angle is cut that this is the larger angle and that this is the smaller angle. Okay, so we're going to take the base from right angle to small, okay, which is 7, and we're going to compare this to the right angle to large leg, which is x. So now we're going to need to take a look at the other triangle which includes x. The one on the left, right? So let me switch colors here so that I can illustrate this a little better for you. So we're going to take this triangle here. Now we need to overlap the right angles and put the small over the small. So this is smaller, and then this is the greater, and the greater over the greater. So we're going to need to flip this so that x moves down here. The small angle goes over the small angle. This large angle gets rotated onto the large angle. And this right angle gets rotated onto the right angle. So what you're going to do is you're going to move it from looking like this to looking like this. And what that does, it rotates this x where the 7 used to be, and it rotates this 5 where the x used to be, or where the x used to be. And what we're going to do then is compare x to 5, because that's the same order that we previously did it. So what you do when you cross multiply is you get x squared is equal to 35, so you take the square root of 35, and I believe that that can't be reduced. If it can, message me, and you get a bonus point. Y. Let's take a look at y. We'll set up the statement for y first. Let me go ahead and undo this work, kind of get it out of the way. Okay, let's take a look at y. So if we remember from last time, this angle here is the small one, this angle here is the large one. So y, which is right angle to large of this big triangle, okay, is to, I believe that's 5 and 7, so that comes out to be 13. So hypotenuse to right to big, so 13 to y is equal to this smaller triangle, which is hypotenuse, y, from right to big, which is 5. So you multiply these out. Let me go ahead and take a look at my sheet because I didn't have time to do that. And it comes out to be y squared is equal to 65, which means y is equal to the square root of 65. I don't believe that can be reduced either. If it can, you get a bonus point. All right. So let me just go ahead and back it up here, try and clear off that figure a little bit more. Okay, now z. We're going to do the same thing for z, but it's going to be from right to small this time. So 13 is to z as this smaller triangle. So where's the right? Right is to, we had right to small, and now we're going to have right to small. So that's going to be z, because that's the hypotenuse. Sorry, I had to think. To this right to small length, and that's going to be 7 here. So 7, which comes out to be z squared is equal to 91. Take the square root. And again, z is equal to the square root of 91, which I don't believe can be reduced. But there are your answers. I hope this helped you guys understand it a little bit more. If you have any questions, go ahead and let me know. I'm sorry if this was a long video, but I hope it helped. Thanks. Bye.